3I/Atlas, also cataloged as C/2025 N1 Atlas, represents one of the rarest and most scientifically valuable kinds of objects ever observed by humanity. A confirmed visitor from another star system passing through our solar neighborhood. Its discovery places it as only the third known interstellar object ever detected, following the enigmatic 1I/Oumuamua in 2017 and the more clearly cometary 2I/Borisov in 2019. Each of these discoveries has reshaped how astronomers think about planetary systems beyond our own, and 3I/Atlas continues that transformative trend by offering a new opportunity to study material that formed around a distant star billions of years ago, long before it wandered into the gravitational influence of the Sun detected on July 1, 2025, by the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS, telescope located in Rio Hurtado, Chile. The object was initially flagged as a faint, fast-moving point of light during routine planetary defense sky surveys. ATLAS is designed primarily to detect potentially hazardous near-Earth asteroids, but its wide-field, rapid-scan capabilities also make it exceptionally well-suited to spotting unusual objects like interstellar interlopers. Almost immediately, follow-up observations revealed something extraordinary. 3I/Atlas was traveling on a hyperbolic trajectory, meaning its path through space was too fast and too steep to be bound by the Sun's gravity. Unlike comets or asteroids that originate in the Kuiper Belt or Oort cloud and periodically return, this object is a one-time visitor, destined to pass through the solar system and continue onward into interstellar space, never to return. The realization that 3I/Atlas came from beyond the Sun's domain elevated it from a routine detection to an object of global scientific interest. Hyperbolic orbits are the defining signature of interstellar origin, and careful measurements of its velocity confirmed that it was moving far faster than any native solar system body at a comparable distance from the Sun. As it entered the inner solar system, 3I/Atlas was traveling at roughly 137,000 miles per hour, about 221,000 kilometers per hour, already exceeding the solar escape velocity. Near its closest approach to the Sun, its speed increased to approximately 153,000 miles per hour, around 246,000 kilometers per hour, a blistering pace that underscored its alien provenance. These extreme velocities are not merely numerical curiosities. They carry crucial information about the gravitational history of the object, indicating that it was likely ejected from its home star system by powerful interactions with massive planets or stellar companions before drifting through interstellar space for millions or even billions of years. Physically, 3I/Atlas appears to be a cometary body, though its exact size remains uncertain. Observations from the Hubble Space Telescope suggest that its solid nucleus lies somewhere between about 440 meters and 5.6 kilometers in diameter. Even at the lower end of this range, it would dwarf any human-made spacecraft, while at the upper end it would be considered a modest but respectable comet by solar system standards. Like other comets, it shows signs of activity as it approaches the Sun, with sunlight heating its surface and causing volatile ices to sublimate into gas, dragging dust along to form a faint coma and tail. The composition of this material is of particular interest to astronomers because it represents pristine matter from another planetary system. By analyzing the gases and dust released from 3I/Atlas, scientists can compare its chemistry to that of comets formed around the Sun, searching for similarities and differences that might reveal how common certain building blocks, such as water, carbon-based molecules, or complex organics, are throughout the galaxy. One of the most reassuring aspects of 3I/Atlas's passage is that it poses absolutely no danger to Earth. Calculations show that it will come no closer than about 1.8 astronomical units from our planet, equivalent to roughly 170 million miles or 270 million kilometers. This closest approach occurs on December 19, 2025, and even then the object will be on the far side of the Sun relative to Earth, making any physical interaction impossible. In cosmic terms, this is a safe and distant flyby, nearly twice the average distance between Earth and the Sun. While it will not provide a spectacular naked-eye display, Its safe passage allows astronomers to study it intensively without any concern for planetary defense. The path that 3I/Atlas takes through the solar system is as fascinating as its origin. Its trajectory is steeply tilted and retrograde, meaning it travels in the opposite direction to the planet's usual orbits around the Sun remarkably. Despite this unusual inclination, its path is closely aligned with the plane of the solar system, allowing it to pass relatively near several planets in quick succession. After its discovery in early July 2025, astronomers quickly traced its inbound direction to the constellation Sagittarius, toward the densely populated central region of the Milky Way. While this does not necessarily pinpoint its exact origin, it provides intriguing context, as that region of the galaxy contains countless stars and planetary systems capable of ejecting objects like 3I/Atlas into interstellar space. As it continued inward, the comet made one of its most scientifically valuable encounters on October 3, 2025, when it passed within about 0.19 astronomical units, roughly 29 million kilometers, of Mars. This relatively close approach allowed spacecraft already operating around the red planet, including ESA's Mars Express and the ExoMars Trace Gas Orbiter, to observe the object directly. These space-based observations were crucial, providing high-resolution images and spectral data that could not easily be obtained from Earth. By studying how sunlight interacted with the gases and dust surrounding 3I/Atlas, scientists were able to refine its trajectory with much greater precision, improving orbital calculations by nearly an order of magnitude. This refinement not only confirmed its interstellar nature beyond doubt, but also improved predictions for its future path through the solar system. On October 29, 2025, 3I/Atlas reached perihelion, the point in its journey where it came closest to the Sun, at a distance of about 1.36 astronomical units, just inside the orbit of Mars. The comet experienced its greatest solar heating. Unfortunately for ground-based observers, this moment coincided with a period when the object was almost directly behind the Sun from Earth's perspective, rendering it effectively invisible to conventional telescopes. However, this did not mean it went unobserved. A fleet of space-based solar and heliophysics missions, including SOHO, Punch, and Stereo, continued to track it against a bright solar background. These instruments, designed to study the Sun and the solar wind, were uniquely positioned to monitor the comet's behavior during this critical phase, capturing data on how its activity responded to intense sunlight. In November 2025, as 3I/Atlas emerged from solar conjunction, it reappeared in the dawn sky, once again accessible to a wide range of observatories. By this time, its tails, composed of dust and ionized gas, were becoming more pronounced, shaped by solar radiation and the solar wind. ESA's JWST spacecraft, along with several of NASA's heliophysics missions, captured additional views of these developing structures. Each observation added another piece to the puzzle, helping scientists understand how an interstellar comet behaves when exposed to the environment of a foreign star. Comparisons with Oumuamua and Borisov became particularly valuable here, allowing researchers to identify which features might be common to interstellar objects and which might be unique to specific formation environments. The closest approach to Earth on December 19, 2025, while distant, marked a symbolic midpoint in 3I/Atlas's journey through the inner solar system. After this date, it began its long climb outward, gradually fading as it moved away from the Sun and its activity diminished. In March 2026, it is expected to pass about 0.36 astronomical units from Jupiter, a relatively close encounter on cosmic scales. Although Jupiter's immense gravity will slightly alter the comet's trajectory, it will not capture it. Instead, the planet will act as a final gravitational slingshot, nudging 3I/Atlas onto a new outbound path that will eventually carry it beyond the heliosphere and back into the vast interstellar medium.